Just a little rundown of where I am with the FX9000P, sort of modifications, fixes and upgrades. This is where it is at the moment. I've got a Pico card in here, if I pull that out. So that's got two Picos there. One's running the display and switches and SD card, the other one is on the bus, and that is doing emulation of the RAM. This circuitry here is now redundant, so this is all for sizing the amount of memory that you're going to emulate and also passing on those signals to cards to the right of this card, which is a bit redundant because this can be a 32K card, so you can't get any more RAM in, so this one card takes you up to the full memory capacity of the FX9000. This logic is still there, but it's not being done in these chips. It's being done in a third Pico, which is on the back and wired in to take over the duties of those chips. Now the advantage of this is a lot less ICs, it's fully programmable in that this Pico here can talk to this one over a transputer link again and change the size of the memory that's going to be emulated on the fly. So you can load an image off SD card, or at least you will be able to when I've written the code, an image off SD card, and that will have with it the size of cartridge that should be emulated, and really it's probably going to be 32K all the time, I think. This is a bit untidy, it's a prototype, wires everywhere. A board's gone off, and I've changed the Picos to RP2040s, which are about this big. Well, they are that big because these are RP2040s. So that's being reduced in size, and even though it's a little bit harder to make, or a lot harder to make, it does make it a much less heavily populated board, and it also makes it lower so that you can actually fit, if you took the switches and the display off, that would fit inside one of the original cases like this. The display and keys are quite useful because you can sort of dump an image by pressing that button there as the machine's running. So I don't know whether to, I don't know what to do about cases. I've been using it with no case, so I think a 3D printed case might work, but you'd need some sort of design around the handle that you've got here, because that's right in front of the display. What is quite nice is that display does poke through the window here, so you can see it with this closed. This USB is just so I can run that board on the bench. That's nothing to do with the final design. So if I turn it on, this starts up, then there's a click there, which is the bus Pico starting up and presenting RAM to the FX9000, which then starts up. So on the display here we've got the normal FX9000, no programs. If I go into the menu and select one of the images that I've already put on the SD card, there's quite a few now. That one there. So there's nothing here at the moment until the light or the asterisk starts flashing at the top there, and that is when the SD Pico has transferred data to the bus Pico. Up until that point it's just loaded it in its internal memory and is running through some status messages. Now if I hit enter, you can see the cursor's jumped down here. Now that's because the cursor, when I saved that image, was actually down there, and the cursor position is stored in the RAM in the cartridge because there's no other RAM on the system other than video RAM. So if I clear the screen and list now, there's a program there, so I can run that with Shift P0 and it's displaying numbers. I'll stop that and we'll go to P1. P1 does some graphics. P2 displays sine and cos, and these are test programs that I've used to test both the cartridge and the video RAM fix, which I did because this came with broken video RAM. F3's got nothing. F4, F7, Now that's looking at the real-time clock on the OP1 option thing that plugs in the bottom, and P8 just displays, I think that might be a cubic curve or something. These are just tests so that I can check things are working. So the cartridge is working quite nicely. If I want to snapshot whatever programs are in there, I just press that button like that and a snapshot's taken. It's very quick. This is running, and I've interestingly I found out, so up until now I've been doing p.size to find out the size of the card that's running in here. So this I think is running as it might be a 12K, but it looks like it's 16K. Because I'm using Picos, I can't run as 32K. I need to do that with an extra GPIO, and that is going to wait for the PCB for the cartridges that have got 3 RP2040s on it instead of Picos, because you get more GPIO lines on those chips than you do on a Pico. So you can also, and I saw this on the internet on an eBay listing, you can also go size and then comp, or E indeed. What's going on there? Something strange happened there. I used the reset. Size, size, comp, and that runs the size directly from the that runs size as a function. So you can use the FX9000 as a calculator by using comp instead of having to do a p.2x6 and enter, and that was where I was getting confused as to how you could run size directly with a single key press. Not sure what happened there with the image, although actually I don't know why it crashed when I hit comp, so there's something strange going on there, but I do know if I load the image back in that we were looking at, which will be either the last one or one back from the last one. Let's load that one in. Takes a few seconds to load, but that will get us back to where we were when I took the image. Right, so let's have a look at size now. Oh, it's up the top there. Right, 1098. The reason for that is that I've got RAM files stored in the cartridge, and that reduces the amount of memory that you can use. So that's all sort of working. The code needs to be updated. I need to handle the Pico that's stuck on the back here and change the card sizes, and probably auto load an image when it starts up so that you don't need to press buttons. You're just back where you started. Maybe the last image that was stored gets loaded back in automatically, so you really are back where you started, and you could just continue pressing the snapshot button to save images. I could do time saves as well, sort of once a minute it does a save, but you'd fill up your card, or at least get a lot of files, which would be a pain to scroll through, but they could be a sort of background image or something. There's a lot of things you can do, it's programmed, so all sorts of things. What's interesting about the display is that it doesn't have these individual chip replacement boards. I've been running with 4 of those. Instead it has a new board, which you can just see here, which has got one PCB that replaces all 8 chips in one go, and that's a new board. It's got RP2040s on it. There's 2 because you need the RAM chip that is used here has got a data in and a data out line, and to make it a proper emulation of that chip I've actually done that. I could probably have done it with a single GPIO because you can't read and write at the same time, but here it's set up to have data in and out lines, and because of the number of GPIOs you would need, you can't do it with a single RP2040 unfortunately, which means there's 2 here, and they're linked together with a transmuter link again, so it's very similar to the cartridge circuit that we've got over there, but this is doing the 4K video RAM, and it plugs into all the chip sockets that I put in, and it turns out that the chip that was in a socket on the end, I've no idea why that was done on every FX9000 that I've seen. The chip, it was just a socket. There was no wiring, there's no fault on the PCB that was being fixed. I had absolutely no idea why that was there, so I took that out and put the same profile socket in as the ones that I fitted when I removed my broken RAM chips, and had these single chip sort of 4044 RAM chip emulators in there. So the whole thing plugs in one go, and you get all 8 chips replaced, which is quite nice, which means I've got a board where I can replace the video RAM completely, or I can fix one chip. But as I've got sockets in there, I'll probably just run with this board, at least for a while I'm testing it. It's quite a new one. Fortunately, I think I've found a method or a process for soldering RP2040s onto PCBs, if not 100% reliably, it's sort of around about the same sort of success rate as I get with other components. The problem being that if you do have a problem with your soldering and it's under the chip, A, you don't know, and B, you've got to take the chip off. You can't just do some remedial action on it. But anyway, it's been running quite well. Of course, the problem I had when I was fiddling with the comp key is the first time I've seen it go wrong at all, actually. So it did that on video, of course. But yeah, so this is storing programs in RAM files, which tends to fill up the RAM pretty quickly because you haven't got a lot. But I am only running with a 16K card here, so let's turn it off and back on and see. Wait for it to start up. There's a big delay there, it's just things happening and starting up, which is why it takes longer to start up. And see what it says here. Do comp, yeah, 15, so it is running as a 16K card. It's a bit confusing because it can run as a 12K or any multiple of 4K, but it is running as a 16K card. And it was when I hit the comp key it all sort of went wrong. I'm not sure what happened there. I don't think there's anything particularly... Yeah, there's nothing particularly dodgy about the edge connector or anything else. I'm not sure what that was. But anyway. So yeah, that's the state of affairs. Got a replacement cartridge. I've got loads of cartridges actually. I've got the new one. New one with batteries on it, and that's purely hardware, and that can also run as a 32K cartridge. The problem with this is if you do use it and you put programs into it, it's difficult to get them out. They stay there with battery backed up RAM, and I've had the battery running for weeks now and it seems okay, so it's definitely going to run for weeks on a battery. The problem is you can't get it into a PC, so I think the best cartridge is the one with the Picos on, because you can take the SD card out and look at the dumps and put new code on there if you want to, so that's a bit more flexible and there's not really any disadvantages to it. The circuitry, once the board comes back with the RP2040s, it's probably, well, there's less ICs on it than this one. It's harder to make, but that's my problem, and or anyone who wants to make one. But yeah, this even though it's totally reliable and works just like the original cartridges, and you can save your programs and keep them there, it's non-volatile. The problem is you can't get anything off. And I've had a thought. Well, I've thought of maybe some ways that you could plug that cartridge into a unit and you read it off like a sort of cartridge reader, but you need an edge connector and all sorts of things. So I think the best one's probably the Pico cartridge. There's no real disadvantages to it other than the fact that you've got the display and the keys there, which don't work very well with the case. The this one here, let's just get the, if I get the RAM one, that does actually fit. No, not that side. It does actually fit perfectly well in the original case. So you can put the board in there. I did make a mistake with that originally and had these holes in the wrong place, but it does actually fit absolutely fine in there, and operates as a 32K or whatever you set it up to be cartridge with battery backed up storage. This one, I mean, you could operate it like that if you left the display and the buttons off, but that sort of negates some of the usefulness of it. Although I think you could communicate with the Pico and do snapshots and load images and so on by setting up a variable in memory which the cartridge, because it's storing all the RAM in the system apart from the video RAM, can see. So with a bit of clever code you could probably communicate, instead of a display you could communicate with variables in the system. So that's one option, and it'll be fairly easy to do. The problem is the Pico needs to then understand the entire format of the cartridge, and I haven't worked that out yet, but I've got some dumps that I can work on that. So yeah, that's where we are. We've got cartridge there and a brand new video RAM replacement board there. Because there's two Picos and they're talking to each other, those Picos, if they share the data over the transputer link, do have full image of what's on the screen at the moment. So you could do some clever stuff there and sort of get screenshots over USB and that sort of thing. There are two USB sockets there. I haven't tried them out yet, but they should work. And there's some other GPIOs and things, so I'm planning to do some bits and bobs with that and see what I can do with that. So it's much, well, I was going to say it's cleverer than using the individual boards, but actually there's less cores. But because you've got the total video RAM in one chip, potentially once the transputer link's up and running, it isn't at the moment, then you can do screenshots and save screens and load them back in and things like that. The only problem's how do you communicate with it, but I have to sort of work on that, I think. But yeah, it's up and running and yeah, it's quite a nice machine to actually use. In fact, I'm going to leave it running, I think. Let's leave it running doing let's load an image first. Quite a few of them there. Oh, there we go. Load that image. Should take a little while. Wait for the light to flash. There we go. Clear the screen, break, and run some graphics.